All right, without further ado, let's get started, and we can continue to let people flowing in as we're doing our introduction. So first of all, thank you so much for joining us today for the webinar. This is a pretty exciting topic. We're going to be talking about enabling observability through the AWS Distro for OpenTelemetry. So this is actually a pretty exciting two-part joint webinar with AWS and Sumo Logic. We're going to be talking about how to set up data collection via AWS Distro for OpenTelemetry and how to enable unified observability in Sumo Logic. So we have two really great speakers with us today. First, I want to introduce Nizar from AWS. He's the principal product manager from AWS, and he leads the team for AWS observability for ingesting metrics and logs and traces using open source solutions like OpenTelemetry. And the other speaker we have today is Pawel from Sumo Logic, and he is the principal technical product manager at Sumo Logic, where he leads the initiative to extend Sumo Logic and the platform to cover APM and tracing use cases. And he has spent many years working in IT organizations, really understanding how best to solve the challenges that customers are facing with digital transformation. So thank you so much for joining us today. And we'll just dive right in. Nizar is going to kick us off with talking about how to set up the AWS distro for OpenTelemetry in AWS.
Thank you, Katie. So, and welcome everyone. Looking forward to this webinar as well as the discussion in the end. So to get started with, I would like to spend some time in kind of going through explaining what OpenTelemetry is, what AWS has done integrating with OpenTelemetry, providing a distribution of the upstream OpenTelemetry project, and what are the components that are being added into this OpenTelemetry architecture to not only support AWS monitoring services such as CloudWatch and X-Ray, but also supporting partners such as Sumo Logic. So let's get started. So to get started, like what is AWS Distro for OpenTelemetry, and why is there a need for building one? So we have heard from a lot of our customers that they use multiple agents and SDKs to instrument their applications. And these applications run in different compute environments such as container services, ECS, EKS, Lambda, on host that's running in the cloud with EC2 or running on-prem. And at many times, customers are using multiple monitoring services. So for different set of use cases or for different set of situations where a team has started using it, an application has already been instrumented and so on. So in the end, customer ends up with using multiple vendor-specific SDKs and agents, which adds development time, which adds management and maintenance time, and it also creates an issue where the data that comes out of these agents and SDKs are not correlated. They work as an island, so you cannot answer questions such as metrics being collected from one agent. How does that correlate to my traces or logs and so on? It's just because the data is disconnected. So in order to address these problems, the open source community came up with a project called OpenTelemetry. OpenTelemetry provides a standardized open source set of APIs, SDKs, and agents, enabling customers to instrument their application once and send the correlated logs, metrics, and traces to any destination of their choice. So for example, customers can just use the OpenTelemetry SDK and the agents to instrument their application and say, okay, I want to send my traces to CloudWatch and X-Ray. At the same time, I also want my traces and logs to be sent to Sumo Logic. So it provides a standardized open source set of framework, APIs and SDKs to get this work done. And in future, if the customer decides that he wants to send this data to multiple monitoring services, they don't have to go and re-instrument the code. The only thing is they go and update the configuration and they can send the same data to multiple destinations. So that is kind of OpenTelemetry in a nutshell. So now what is the AWS distro for OpenTelemetry? What has AWS done? So the AWS distro for OpenTelemetry is a secure, production-ready, open source distribution of the upstream OpenTelemetry project. 100% of our code that we are adding goes to upstream first. So from code perspective, it is exactly the same. What we are doing is we are taking a distribution, we are taking a snapshot of the upstream project. We are running that through various security testing, performance testing, integration testing, analysis, and making it ready to be used into a production environment. We have integrations with services such as Lambda, ECS, EKS is coming shortly, so that customers can just either use an API or have a one-click console experience to use the AWS monitoring services. Not only that, in this AWS distribution, we are supporting modules or components so that customers can send the data that they are collecting to any monitoring partners. And Sumo Logic is one of it, and we'll see how customers can do that from the setup standpoint as well as the value proposition. And Pawel will kind of give an end-to-end demo to show the experience of using the AWS distribution with Sumo Logic. So since we looked at like kind of the why of why we created this AWS distribution, why we are aligning with OpenTelemetry from AWS standpoint, let's look at what a target customer is, like how we define a target customer. So a customer who is looking for a standardized set of open source APIs to collect their metrics, logs, and traces. Also, the customers who want to instrument their application once and then decide where they want to send the data later on, add or remove providers and so on, without having to re-instrument the code. And then the other set is of the target customer is a customer who wants to use the wide set of SDKs and language support that comes with OpenTelemetry. So today, OpenTelemetry comes with 11 SDKs plus auto instrumentation agent in Java. We are continuously working to provide auto instrumentation agents in .NET. We have some capabilities of auto instrumentation in Python and so on. So it's like you have a wide set of language support automatically from get-go. Okay, so we looked at the why of OpenTelemetry, who is the customer, and so on. Let's go deep into understanding what are the different components in OpenTelemetry and what has AWS done to enhance that these different components and how we integrate with AWS monitoring services as well as the partner services like Sumo Logic. So to start with, we have on the top we have an application code, and this application code can run on ECS, EKS, Lambda, EC2 on-prem anywhere. OpenTelemetry provides two different set of components, right? One is in-process components and one is out-of-process components. In-process components are the components that run within your application process, right? So these are the auto instrumentation agent that runs along with on the same host or same container on the application process. It also provides a set of APIs, SDKs that can be extended. And then the question is, how do you collect? So the APIs and SDKs helps to collect the traces, metrics, and logs, and then you want to send it to the monitoring backend, such as CloudWatch or Sumo Logic or any other partner. So there are two different ways you can do that. One is in-process exporter, where you can directly call the backend service, such as Sumo Logic or X-Ray from your application code. And the other one is through an out-of-process exporter, which is embedded as part of the collector. So collector consists of receivers, exporters. It runs as an out-of-process service as part of a sidecar in your container or as part of a Lambda extension. And it does the same thing. It takes the data from in-process exporter as in a default format, batches and collects the data and sends it to monitoring services. There is another way of sending the data or collecting the data is through scraping. So there are clients that runs as part of your application code. It scrapes the data and sends it to the collector. The collector then sends it to the monitoring service. Sorry. So now let's take a look at what AWS has done in terms of enhancing this architecture. So to start with, we have extended the OpenTelemetry SDK to provide support for automatically collecting AWS resource metadata information. By that, I mean, like, if the code is running on a container, we automatically collect resource information such as container ID, pod ID, container on, instance ID, Lambda function name, Lambda function version. And that is already integrated as part of your trace data and other data that is collected, so that you can correlate the application performance to the infrastructure performance monitoring, and create an experience of understanding whether a downtime in the application, does that impact, is it because of an infrastructure issue, or is it because of another issue that's related to the application. Second, we have added support for X-ray. So X-ray trace ID. So X-ray has its own format of trace ID. And we added extended OpenTelemetry to support supporting an X-ray trace ID. And also we are enhancing the exemplars and working with upstream to provide the correlation between metrics and traces and so on. From the auto instrumentation standpoint, which automatically collects your trace data, again, we have added support for AWS SDK. So for example, if you're running a Java application on a container and you drop in this agent as part of your application startup process, and you have AWS calls that you're making, either calling an AWS API or a DynamoDB table and so on, automatically those calls get instrumented and automatically trace spans get collected as subspans and so on. So without doing without adding any instrumentation code or without changing any code. So we have done integration with AWS SDK as well. And again, support for the X-ray trace ID. And then finally, we have added functionality into the collector, right, in form of exporters. So we have added specific exporters for AWS monitoring services such as CloudWatch and X-ray. And as part of that, we do the conversion of the data from an OpenTelemetry format into an X-ray format and so on. So in terms of exporters, what we have added is we have added the tracing exporter for X-ray. At the same time, we have added the OTLP exporter, which is the default exporter that comes with OpenTelemetry, which Sumo Logic uses. So you can send trace data to Sumo Logic as well. And for metrics, we have added CloudWatch metrics exporter. We have enhanced the Prometheus exporter, and you can send all that data to other partners as well. Cool. So just through this session, right, we understood what we did in terms of like why is OpenTelemetry important, what AWS is doing, who is the target customer, what are the different architectural components, and so on. Now let's take a look at Lambda is a unique and a special case where which is a function as a service. You don't have to manage any of the infrastructure. You just provide your application code and Lambda will run with it. So in order to provide support for OpenTelemetry, there were certain nuances and certain things that we wanted to do, which is very much aligns with our partnership with Sumo Logic, and you'll see how in the demo that Pawel gives. So in order to add support for Lambda, today we have support for Python, and it's based on Lambda extensions. So Lambda extensions was launched in preview sometime end of last year, and it helps customers to bring their own agent in summary. And so what we have done is we have created a Lambda extension for OpenTelemetry or for AWS distribution, where the collector and SDK is running as an extension, and it's all packaged as part of one layer. So when you run a Lambda function, you can create a Lambda layer for OpenTelemetry, and you can add it to your function, and you can start instrumenting and use open source APIs and SDKs to do that. Also, as part of the support, we have enhanced the instrumentation libraries to support AWS SDKs, so that when you're making an AWS call from your Lambda function, for example, from the Lambda function, if you're inserting an item in a DynamoDB table, or you're calling an API gateway API, or you're inserting a message in the SQS queue, automatically those calls get instrumented without you doing any manual instrumentation or changing your instrumentation code. Again, as I said, as part of this, we are also collecting resource information from the Lambda function, and this resource information includes the function version, the function on, so that you would know like what function is being called as part of your trace data and so on. And as part of this Lambda extension, we have also added the OTLP exporter as part of the Lambda extension, so that you can very easily send your trace data to X-Ray as well as the partners who are using OTLP protocol, which is Sumo Logic is one of them. Now, at a very high level, let's look at the flow of the path or the flow of the call when we are using the Lambda extension for OpenTelemetry. How does the data collection happen, and how and when we send out or we flush out the data to any of the monitoring services, right? So we have an invoke. Let's say the Lambda function is being invoked. We have a Lambda layer that contains the OTel SDK and the OTel collector, and it pushes out the telemetry data. The SDK now has the telemetry data, and we batch that telemetry data for 5 seconds. And the reason we do this batching is because we don't want to keep pushing all the data as it comes, because it might add unnecessary overload or network traffic and overload on the backend monitoring services, and you might be throttled. So we are batching the data for 5 seconds. Once the timeout is reached, automatically the data is flushed and sent to the collector. And then from the collector, we push through the exporters, we push out to the monitoring services like X-Ray, Sumo Logic, and other partners. And it all depends on simple configuration on where you want to send the data to. Now, let's say we end the execution of the function. So the function execution is completed. What we do is we do a force flush even if the timeout is not reached, so that we ensure that the data that is being collected or buffered is flushed out and we don't lose the data. So we do a force flush. Again, it follows the same path. It goes from the SDK to the collector. Collector then sends it to the backend monitoring service through the exporter. And since this call is a synchronous call, we wait for this call to happen. We wait for the push to happen to the monitoring services to ensure that we are not returning the call back to the user until the data has been sent, to ensure that we don't lose any data and all this valuable data that is collected for monitoring, we are collecting it. Okay, so that being said, I want to spend like just a couple of minutes before I hand the control to Pawel, where he goes deep into how Sumo Logic is using these things to create a triaging experience on their side. So as part of the AWS distribution, we have launched a developer portal on GitHub. And this developer portal, and maybe I can just open it up very quickly. 1 second. Okay. Okay. Hopefully you guys can see the developer portal. So this developer portal is one place where developers can come and learn about AWS, what AWS distribution for OpenTelemetry is, what is its value proposition, its benefits, its use cases, and also understand, learn about what we have launched recently in terms of our launch announcements, our recent blogs, and so on. We also have a public roadmap over here, so you can just look at the various roadmap, and we have monthly releases for the AWS Distro. Again, we are very open in terms of our upcoming roadmap plus what we are doing. Our next release is towards the end of April. You can also come and the key component is like you can come and download the code right from here. So there is There are collector versions. There are different SDKs, which is just upstream. But mostly over here, there are two things. You can get the collector, updated collector version, as well as the auto instrumentation agent. And one of the important things is the documentation. Right. So this is one place where we try to kind of provide information about the getting started experience, how you can deploy the collector, especially when you're running different environments such as ECS, EKS, on-premises, or Windows, when you're using different languages such as Java, JavaScript, Go, when you're using different exporters, if you want to send data to X-Ray, CloudWatch, and so on. And especially when you want to send data to our partners through OTLP. So if I go down over here, we'll have different examples on the support for Sumo Logic. So you can come right over here and understand what setup you need to do to send the data to Sumo Logic. What is the API key? What is the URL that you're going to use, and how do you set up? So this is kind of one place where you can get answers to the getting started experience, no matter what compute you're using and where you want to send the data to. So that being said, I want to hand it over to Pawel to take it to kind of show how Sumo Logic fits into this and how Sumo Logic is using this to create a triaging experience on their side.
Thanks, Nizar. Hello, everyone. Pleasure to have you on our joint webinar. And quickly summarizing for the great part from Nizar. Great news, AWS is joining OpenTelemetry. When we started our journey, Sumo Logic journey with OpenTelemetry a year and a half ago, that was basically a baby project in alpha stage, but we saw a lot of potential, and our prediction was that more and more vendors will start getting interested about this. So great news that biggest cloud provider on the market is actually joining the community and helping us develop that framework, that great thing that provides a lot of value to you, to our customers. And let me spend a couple of minutes to explain, first of all, introduce Sumo Logic, explain who we are for those of you that are new, that don't know us, or maybe didn't have a recent update about how much we changed in a recent year or two, explain why we have decided to use OpenTelemetry for our APM tracing use cases, and then do a live demo about how that data collected through the collection layers that Nizar has explained, how that data can be manifested in Sumo, and how that can help you troubleshoot and increase reliability of your applications, because this is really what it is all about. Observability is not an aim on itself; it's a way to the end goal, and the end goal is increasing the reliability of modern applications. This is why we are building this unified observability platform, that by collecting the observability signals, metrics, logs, traces, enhanced with the common metadata from any type of source, including Sumo Logic, but also open source sources, including OpenTelemetry and including AWS Distro of OpenTelemetry, can help you monitor, diagnose, and troubleshoot your applications. Why I believe this is important? This is important because it's very easy to do something like that if you have your common proprietary agent, but it's not very easy to do if you kind of cover a plethora of open source sources of your data, and you need to synchronize all of them in a cohesive end-to-end top-down picture of your environment. But that's exactly what we do. That's how we are different than the other vendors. We fully support open source. We fully support open source data. We can live only with open source data. We don't require anything, any proprietary code to be installed in our apps to collect that data. Still, we have to provide very similar experience, very similar, natural, intuitive workflow, stitching and ditching the data to provide the answers and to provide you these analysis, regardless of the type of the signal you are ingesting to the platform. So why OpenTelemetry? We think from the customer point of view, there are really three main points why OpenTelemetry is so attractive, and that's the things we have learned talking to our Sumo Logic customers over past 2 years, when we have been, looking closely at that new initiative that appeared. I think in a month or two, it will be actually exactly two years when OpenTelemetry appeared as a merger of open census and open tracing standards. First of all, the customer can own the data. This is very important because ownership of the data in logs world is something obvious. You generate the log and you send the log to the platform. With APM or tracing data, that wasn't so obvious, right? But if someone would come and say, hey, you need to install the agent to actually start producing the logs, and I'll decide how to produce the logs, and I'll decide how you can analyze this, that would be something weird for you. And that's exactly what's happening with tracing or APM data. So unlocking that data, giving that data into the hands of the customer, making sure that they can enhance the telemetry that signals according to their needs, and making it open and standardized among the vendors. This is really very important thing here. Visibility. The community, especially supported by many big vendors like AWS, will be always faster to provide wider support. AWS has joined OpenTelemetry maybe 3-4 months ago. We already have support for Lambda, for Python. Java is coming this month. Java, Node.js for Lambda is coming next month. This is the power of the roadmap and community support on that innovation and extending visibility to many different areas. Finally, the cost, not only because it's open source, it's free, but think about the vendor lock-in. If you install a vendor proprietary instrumentation that can talk only to that vendor's backend, then changing the vendor to another one, it relates to a huge cost of redoing the whole instrumentation. And you have to do it at once, because otherwise you're going to lose your visibility. So you don't want to do that. You want to avoid that, and OpenTelemetry is a perfect solution to that, because you can basically just redirect by a configuration mean traffic from one source to another, from one vendor to another, or even send data to multiple vendors, as Nizar mentioned, and you're all set. That trend, the trend of customers adopting more and more OpenTelemetry, has been already discovered last year in a Magic Quadrant for APM, and also in another paper from Gartner about monitoring and observability of modern services. All of these sources expect the footprint and adoption of OpenTelemetry to rise dramatically, and they're already advising customers to start thinking about adoption of these standards. And that's exactly the goal of our webinar, to explain how you can do that with AWS and Sumo Logic. One thing to understand is the roadmap and maturity of OpenTelemetry. You might remember I mentioned that OpenTelemetry actually appeared as a merger of open census and open tracing. These were the standards for tracing data. That's why, no surprise, the tracing part of OpenTelemetry is the most mature one. And this is, by the way, what we're going to focus our demo today, because that's the most mature and stable data that can flow through OpenTelemetry. But obviously, metrics and logs are following that path. Our colleagues from AWS contribute a lot to the metrics part. We, as Sumo Logic, contribute a lot among other vendors to the logs part, where we are actually working on defining the standard for that type of a data. But again, today's focus for Sumo Logic and for demo is for tracing. Of course, we're going to show the logs and the metrics, but these are not going to be the logs and metrics retrieved through OpenTelemetry. But as you're going to see, it is actually very transparent. You can pivot between these signals completely transparently in Sumo Logic, even not knowing how they have been collected and whether they came from OpenTelemetry or not. So why do we need trace data at all in Sumo Logic or any other observability platform? There are really three main areas of outcomes. So first of all, you want to realize application service level monitoring. You want to understand how your application infrastructure is performing, what's their health. Are there any errors? What are the latencies? Are there any slowdowns? how does it map to the infrastructure? You need to understand the dependencies between different application components. The best visualization of that is service map, where you have a diagram flow like the one behind me that connects those different services and show how that data flows and how these services depend on each other with their health. Finally, you can drill down if you see any red, if you see any spikes, and that's exactly what we're going to demonstrate. You can drill down to the low level of a single transaction. You can understand what was the contribution of different parts, different services, different parts of your application infrastructure into the end-to-end duration of that transaction. Finally, drill down and investigate each of the calls inside the trace, inside the transaction, to understand the whole metadata, and then pivot to the infrastructure to check the health that is supporting that trace or that call, or to drill down to logs to if you see any errors, to check what the logs are saying about this particular error. So how do we collect the data? Obviously, AWS OpenTelemetry collector and OpenTelemetry distribution is helping here a lot, comparing to how it was before. So 6 months ago, even. Sumo Logic has actually adopted OpenTelemetry collector by itself quite early. So we have our own distribution, and we're actually quite agnostic whether you are going to use our distribution. It has some goodies, especially in Kubernetes environments, but I'll mention that in a second. But in AWS environments, it might be actually easier, or in some cases, preferred way to use AWS OpenTelemetry collector and send data to Sumo. Again, both options are available. They differ slightly in the details of the metadata that is collected, but we support fully both options. Obviously, we're aiming at that long-term goal that AWS OpenTelemetry collector is basically an AWS service, and it's as easy to deploy in your AWS account like deploying API gateway or a new Lambda function or a new EC2 instance with a single click of a mouse. That's Nizar's goal that he didn't mention, but I'll do that for him. Right. So what actually flows into OpenTelemetry collector? I have decided to divide it into 4 different, let's say, scenarios. The first is the auto instrumentation. There is a whole set of agents. Nizar mentioned Java. Java is the first auto instrumentation that is supported for X-ray. For Sumo Logic, actually, you can use any type of auto instrumentation available. And right now, in stable state, we have Java, we have Node.js, we have Python, Ruby, including Ruby on Rails, we have .NET, and a couple of others less important languages. So as you can see, pretty good coverage for modern microservice languages. Lambda functions, Nizar mentioned these layers, so that's another source of the data. Manual instrumentation that you can also do with OpenTelemetry SDKs. You might want to do manual instrumentation in 2 cases. First of all, you want to be very precise and granular in what data is produced. Second of all, you have a very specific framework that is not supported by auto instrumentation. Then one of the good things about OpenTelemetry is that you don't have to go to your vendor and ask for putting a roadmap item and try to support it in next year or next 2 years. You can basically build something like that yourself for your needs, using the standards, using the specifications, and you have a guarantee that if that data meets the specification and the standard, you can just send it to Sumo. You don't even have to tell us, and that data will appear in the system. Finally, the browser instrumentation, that's also quite interesting offer from OpenTelemetry that is in early stages of adoption, development, and maturity. We have actually that in the beta in Sumo Logic, and we will also cooperate with AWS to mature this instrumentation to provide more insights into end user experience in your browsers, and also eventually as a next step other devices like mobile. So that data collected by the OpenTelemetry collector goes to our receiver, which is basically an HTTPS endpoint in the Sumo Logic cloud, and once the data flows into Sumo, you have all sets of these nice visualizations that you can use and leverage. Right, I wanted to take us one step back here and tell something about how we collect data in Kubernetes environments. You might remember from previous slides that we're using OpenTelemetry collector mostly for tracing because it's highest maturity in that area. But for Kubernetes, and that's also true for Kubernetes, where OpenTelemetry is used to collect the traces. But for Sumo Logic, dedicated collection layer for Kubernetes, we're actually using other open source collectors also to collect various signals. We're enriching that with the common metadata, and that way you have a guarantee that you can always find your signal regardless of how it appeared in the system in the context of the entity that you're analyzing. We also have a plan to expand OpenTelemetry over these other collection methods as the OpenTelemetry matures and is able to collect properly metrics and logs. We'll be extending footprint of that component in our collection layer, even for Kubernetes and other environments, finally navigating at the stage where all our collection for all three observability signals is done solely with OpenTelemetry as a collector component. All right, so let's jump to live demo right now. Let's open Sumo Logic platform and let's log into this. So we are using the live system here that we are actually feeding log metrics and traces from two environments that are hosted on AWS. I first want to start with showing you how you can build a top-level dashboard with Sumo Logic that shows you the health and KPIs of different data for environment working on AWS. Let me maybe start with this. So the service map is the high-level view of your environment, something that allows you to see how your services are connected together. So this is the view of your application infrastructure. As you can see, we have a couple of applications here, and a couple of them are actually read already. And I want to focus maybe first on this one here on the left that is called the Coffee Bar app. So I'm going to filter just on this one and just quickly try to understand what is the flow. As we can see, the coffee lover is the initial microservice that is, an entry point to the application. Then that goes to Coffee Bar and Coffee Machine, which goes to machine service for water and coffee, and then to the cache desk for calculator and our PostgreSQL database in the backend. So as we can see, there is some red for three initial microservices. We see a spike here. That's why it is red. We have detected anomaly, and we see that that anomaly flows from the lover to Coffee Bar and then to Coffee Machine. So let's try to analyze this problem in more details. Let's try to first see the whole application on a single dashboard to understand what's going on there. So as you can see, we have that spike presented here. We can actually see that there is actually that coffee lover in yellow, the first microservice that has the spike. So let's hide it, and then Coffee Bar is the second one. And the third one and the last one that has a spike, if we hide it, as you can see, that chart actually goes to only flat lines. So this is really the last microservice that has a problem, and that actually corresponds with the view we had here, right? So the Coffee Machine is really the last service that had a problem. So we already have a hint of what might be going on here. Let me maybe click on that and go to see the particular entity dashboard, so the dashboard of that service. I don't really have to do that, but I just want to show you another dashboard that you can go one level down. We have actually all services here on that list for that application, so we can analyze all of them one by one if such need arises. But really on the previous dashboard, I can do exactly the same as on this one. I can click on the chart, I can go to infrastructure, and I can go and search for traces. So basically trying to understand in details the performance of the transactions that has been executed during that time. Let's maybe try to do this. I need to click on that once again. Right, so let's try to find this for last 60 minutes, and let's try to find the traces that basically had the biggest duration. Right, so as you can see, we have these, we had the spikes at 8:30. I'm in Europe, so that's why you see 8:30 p.m. And we can, for example, select one of these traces as an example of the error of the latency. So let's maybe pick the one that has the error as well, so we can also analyze the error. So let's start with this. Let's leave the latency for later. Let's analyze first what was the error. These red bars here actually indicate the error, so we can click on that span. We have all the information about that span. We have all the metadata, and we can very quickly, by clicking on that link, go to the logs of that particular trace and basically see that the error here was related to the customer not having enough money. As you can see, very seamless navigation, because we're using this metadata that we have in a span to pivot between traces and logs. And in second case, actually, when we're going to analyze why actually that span took so long, rendering the whole transaction for a very long time, if we go to infrastructure, we can actually analyze the performance of the container. As you can see, there is a spike here, exactly at that moment when the application had a problem with latency, which manifested in so long spans. We have also a spike in the CPU, and we have spike in the memory usage. We can check that the same thing happens on the pod, and we can also see that there's only one pod running in this replica set. We can click on that and go analyze in more details the behavior of that that deployment of that replica set, to see how many pods we have, to see what were the spikes and why exactly that behavior of the deployment was observed. As we can see here, the CPU actually jumping over to the limits, and that doesn't result in any new pods being created. So let's leave the infrastructure part. Let's go back to the tracing part. I wanted to show you one more thing. I wanted to show you how that data actually looks if we would be running this on the ECS environment in Fargate with some Lambda functions, because obviously we have been talking a lot about what good things AWS is providing in regards to monitoring of Lambda. So I wanted to show you a couple of examples how that type of a visibility can look for you if you enable this for Lambda functions. So very similar transaction. We have just added here a couple of Lambda functions that generate the spans. As you can see, this is Lambda check suites function. This data actually is generated with AWS Lambda layer for Python. You can actually see it here. You have Python, you have OpenTelemetry that goes over AWS OpenTelemetry collector running in the layer down to Sumo Logic. So we have all details about the account ID, cloud infrastructure type. We have the fast execution ID. We have the fast ID, fast name. And of course, this metadata allows us to connect the dots and get the metrics that we take from CloudWatch with our AWS observability feed and module, being part of the overall observability platform. So these metrics are not tracing metrics. These metrics are actually metrics that we're taking via another data source from AWS CloudWatch from your account. And you can, by clicking on this and opening entity dashboard, you can actually jump to the dashboard of that particular Lambda function, and you can investigate all the metrics in details, basically automatically drilling from the Lambda function from your trace to your metrics. So you can analyze the requests, you can analyze the performance trends, so you can understand, what kind of performance you have here, what kind of, function duration, how many concurrent executions. We can actually try to extend it to 24 hours. I'll try to show you that interesting unused memory predicted and max memory used predicted. These predicted metrics are actually, AI predicts what will be the memory CPU usage and unused memory moving forward. Obviously, we have pretty flat metrics here, so it's quite easy to predict, but you get the point how that works. We can also check the resource usage if you're interested in the costs and controlling the costs. You can understand, how much duration all these Lambda invocations are taking, how much of that is going to be built for you, and look at other metrics related to memory, to duration, to compute usage, etc. And of course, if you're interested in learning more about the logs of that function, you can also find them here, or by clicking anywhere here. Again, in similar way, you can jump and drill down to logs of that particular function, taken from your account, from the namespace Lambda for that particular function execution. So as you can see, pivoting between metrics, traces, logs in Sumo, taken from different sources. We have covered at least 5 sources here. So tracing over OpenTelemetry, metrics over Prometheus, logs over CloudTrail, metrics over CloudWatch, all of that in a single product with seamless navigation between the signals in the context of the entity that you are monitoring. That's exactly what we do in Sumo. So just summarizing, all of that is part of a single observability platform. It's not a standalone tool for OpenTelemetry or not a standalone tool for tracing. A single product, single observability platform for all observability signals taken from different open source sources of data, correlated together using a common entity model for seamless navigation. Open and flexible, again, we're promoting and investing a lot in open source data collection, including OpenTelemetry without vendor lock-in. Scalable and secure by design, FedRAMP certificated, and famous scale of Sumo Logic data for terabytes of data per day per customer, not a problem for us. Common grade analytics for traces, metrics, and logs. We can actually run Sumo Logic search queries, search query language for any types of these signals, including tracing for any kind of custom analysis. Very attractive pricing, volume-based, pay as you go, without any, pricing penalty for number of services or complexity of your environment. Finally, available through AWS Marketplace, because we're long-standing partners with AWS, so you can also buy Sumo Logic from there. So that's all from me. Thanks very much. Here's a couple of resources for you if you want to read more or get started with either AWS OpenTelemetry or Sumo Logic. And yeah, I'll get back to you, Katie. Thank you.
Awesome. Thanks so much. Really awesome demos. We're going to open it up for questions. If you have questions for Nizar or for Pawel, and we also have, let's see, a couple questions already. So let's go ahead and get started. The first one, Nizar, this is for you. What's next on the roadmap for the AWS side of things?
Yeah, so the AWS roadmap can be divided into kind of multiple big areas, right? So the first primary goal for us is to get the AWS distribution to a stable state for tracing. And for that, we are working with the upstream community to get the collector to a stable state from the tracing experience standpoint. And that is what is being targeted to end of June. So from that point of time, the AWS distribution, along with all the OpenTelemetry components, would reach the stable state for tracing, and customers can use that in the production environment. So that's one area of investment. The other area of investment is around supporting more languages. So we are expanding language support specifically on Lambda. Today we have Python. This month we are launching 2 more languages. The next month another 1 or 2 languages, and so on. So that's very Lambda specific base. And also we are launching an AWS managed layer. So instead of customers creating and building their own layer for Lambda, we will build an AWS distribution for OpenTelemetry layer. So customers don't have to go and run commands or use SAM tools to build the layer. They can just search for the layer, add it to their function, and they're done. So that's the second part. The third part of investments that we are doing in parallel is ensuring that the metric specification is locked and loaded, and the APIs and SDKs are ready for supporting metrics the way we are supporting traces. So reaching metrics towards the end of the year as a stable launch part of the entire distribution. That's on the metric side. And in parallel, we are working with the community on the logging side to define the specification, integrate the existing agents that some of the partners are contributing, and reach to an area towards the end of the year where we can say logs, metrics, and traces are now available. Logging is a little bit behind because the specification has not been locked in. So that's kind of the general overall roadmap. Again, as I shared, and I think it's even in the screen, we have public roadmap. We continuously update that on a weekly, bi-weekly basis. So you guys can kind of take a look at it, as well as contact us via email or through our Twitter channel, and we'll be able to answer those questions, specific questions if they have.
Awesome. Thanks so much for that. Let's see, a couple other questions here. This one is for you, Pawel. How does the service identify the infrastructure that is the infrastructure associated with it?
All right, so this is exactly the magic we do with the metadata. So we have a artificial intelligence built in the platform that is able to stitch together the different signals coming from different sources of data. In our example, we actually have traces collected with OpenTelemetry collector on Kubernetes, and metrics collected from the Kubernetes pods on which these services have been running, collected with Prometheus. And the common collector that we use have been able actually to use the common metadata to tell which pod is supporting which span. And that made us available to drill down directly from the long-running span to the CPU and memory metrics for that pod that was hosting the application code that generated that long-running transaction. Similar example of drill downs, however done slightly differently, was the drill down between the Lambda function span and the metrics from CloudWatch. Obviously, these things are not collected through the same collector. The Lambda spans are collected with AWS OpenTelemetry collector in the layer, and the CloudWatch metrics are collected through the CloudWatch APIs or the metrics Firehouse integration. But because we have the ARN, we have the ID of the function that is present in the spans and in the metrics, we're able to stitch these things together and basically seamlessly drill down between the Lambda trace and the metrics taken from the CloudWatch.
Awesome. Thank you for that. Great answer. Let's see, we have a couple minutes left here. Nizar, this one is for you, and I know you kind of covered this, or you definitely covered this at the beginning of the session, but maybe you could just kind of summarize, the primary benefits of using the AWS OpenTelemetry distribution over the non-AWS distribution.
Yeah, so the primary benefit for the AWS distribution is it is a secure and a production-ready distribution of the upstream project. 100% of our code that we are adding as AWS goes to upstream first. So we are not creating a separate version, or we are not forking the project. We are not doing anything like that. Everything is upstream. What we do is we just package it, make it production ready, secure it for running production workload, and it's backed with AWS support. So if the customers are using the AWS distribution, and if they encounter any issue, no matter where they're sending the data, they can open a support ticket with AWS using their support contracts, and will be able to get the support team help plus engineering help as needed. The other benefit is we have and we are continuously improving our integration with compute services. So for example, we are creating this managed layer, AWS managed layer. Eventually, we will have better getting started experience in EKS and ECS, so customers don't have to deploy and manage and run the collectors and so on. So it's kind of it is secure, production ready. It's ready for production use. It's well integrated with compute services in AWS, and it's backed with AWS support.
Perfect. And maybe just one final question for Pawel. So what's the best way to get started with the Sumo Logic, extending this to Sumo Logic if you're already using AWS?
Yeah, so there are basically two ways. First of all, we strongly recommend you, especially if you're interested in tracing, to get in touch with our with our sales team, because there are a couple of things that will be important for you. Obviously, there is a free trial. However, a small chunk of the functionality there is not still available through the free trial till the next month. So it's best to contact our sales teams. And then depending on your environment, you will want either to use the Sumo Logic OpenTelemetry collector, or if you're purely AWS shop, for example, running ECS or Fargate workflows, especially Lambda, your better choice would be AWS collector. Configure and set it up to send data to Sumo Logic, enable the traces source on the Sumo site, and enjoy the data in Sumo. That's basically all you have to do. If you want to learn more, there are a couple of resources here on the list. You can start with the Sumo Logic AWS Auto partnership on our blog. You can also find my other blogs there where I speak a lot about tracing and APM in Sumo Logic. And if you want to figure out more about how the product works specifically, there's also a good link here about getting started with transaction tracing. Obviously, everything based on OpenTelemetry there.
Amazing. Thank you so much. I think we're right at the top of the hour here. So I want to thank our presenters for amazing content, and all of the attendees for those great questions. And definitely join us for the next webinar.
Thank you, Katie, and thanks everyone for attendance.